Hello friends, I'm Dr. Padmavati and I'm glad you're watching this video series on quantitative aptitude. In this video, I will be discussing the shortcuts and tricks on the topic boats and streams. In this video, I have derived 6 basic tricks which will help you to quickly solve any question on boats and streams. In my next video, I will be using these tricks to solve the questions. Moving to the basic concepts. Downstream. The direction along the stream is downstream. That is, if a man or a boat is moving along with the flow of water, then it is known as downstream, whereas upstream is the direction against the flow of water. Moving further, let the speed of a boat in still water be x km per hour and the rate of stream, that is the rate at which water is flowing, be y km per hour. Then the downstream speed will be x plus y km per hour and the upstream speed will be x minus y km per hour. This concept is very much similar to moving in the direction of gravity and moving against the gravity. It is obvious that when a boat or a man moves along the direction of the flow of water, the speed is more, whereas if the movement is against the flow of water, the speed will be less. Moving ahead with the basic tricks, let A and B be the downstream and upstream speed respectively. Then we can write A is equal to x plus y and B is equal to x minus y, where x is the speed of boat in still water and y is the rate of stream. If we add the two equations, we get A plus B is 2x. That is, the rate of boat in still water is A plus B upon 2. Similarly, when we subtract the two equations, we get A minus B is equal to 2y. That means y is A minus B upon 2. These two equations are useful when we are given the downstream and the upstream speed and we need to calculate the rate of boat in still water and the rate of stream. Let us assume that a man can row at the speed of x km per hour in still water and he rows the same distance up and down in a stream which flows y km per hour. Then what is the average speed of the entire journey? As we know that the downstream speed is x plus y and the upstream speed is x minus y. Let us suppose that d is the distance which the man travels one way of the journey. That is, the total distance covered is 2d. Then we know that the average speed is total distance upon total time. So we now proceed to find out the total time. The total time t will be the time taken to cover downstream as well as the upstream part of the journey. The time is nothing but distance travelled upon speed. That is, the total time will be distance d upon the downstream speed plus the distance d upon the upstream speed. If we further solve this equation, we get as LCM x plus y, x minus y, and if we further solve the numerator, we get the equation like this. Moving further, we get this as dx minus dy plus dx plus dy upon x plus y into x minus y. The total time will therefore be 2 dx upon x plus y into x minus y. We now get the total time. Average speed will be equal to the total distance travelled upon the total time taken. Cancelling out the common terms, we get the average speed is equal to x plus y into x minus y upon x. This formula can directly be used to solve the question. The next category will be the distance travelled in the journey. Let us suppose that the same distance d is covered but it takes t hours more to row upstream than downstream. So let us calculate the distance travelled in the journey. We know that the time taken for downstream journey will be distance travelled d upon the downstream speed. Let us call this time as t1. Similarly, the t2 time will be the time taken to cover the upstream journey. It is given that the upstream journey takes t hours more than the downstream journey, that is t2 will be equal to t hours plus t1. Substituting the values, we get t2 is equal to t plus, we substitute the values of both t2 and t1, that is d upon x minus y will be t plus d upon x plus y. Solving both sides of the equation, we get d upon x minus y is equal to t into x plus y plus d upon x plus y. We need to find out the distance d. Therefore, we cross multiply and we get the following equation. We further open the bracket and we leave this term as it is because we need to only find out the distance. Cancelling out the terms, we get 2 dy is equal to t x plus y x minus y, and this gives us the total distance travelled d is t into x plus y x minus y upon 2 1. Again, this formula is useful to directly solve the given question. A man rows a certain distance downstream in t1 hours and returns the same distance upstream in t2 hours. If the speed of stream is given as y km per hour, then what is the speed of man in still water? As it is given that the distance travelled along both sides of the journey is same but the time is different, therefore we utilize this part of the question to derive a formula. We know that the time taken to travel distance d downstream will be d upon x plus y, whereas the time taken to travel distance upstream will be d upon x minus y. It is given that the distance is same, therefore from this equation we call it equation 1 and 2. From equation 1 we get d is equal to t1 into x plus y and d is equal to t2 into x minus y from equation 2. Equating both of these terms, we get t1 into x plus y is equal to t2 into x minus y. We want to find out the value of x. So, solving further, we get t1x plus t1y is equal to t2x minus t2y. Bringing all the like terms, that is the terms containing x to one side and y to the other side, we get t1x minus t2x is equal to minus t2y minus t1y. Taking x common, we get x t1 minus t2 is equal to minus y t2 plus t1. That is, x is equal to minus y t2 plus t1 upon t1 minus t2, or this can be written in a more simple manner as x is equal to y t2 plus t1 upon t2 minus t1. This gives us the next formula. If it is given that the speed of boat in still water is x km per hour and the rate of stream is y km per hour. Also, it is given that the total time is t hours to cover the entire journey. Then what is the distance between the two places? Now, we are given the total time t, which is the time taken to cover downstream and the time taken to cover upstream. We want to find out the value of d. This can be further solved as d into x minus y plus d into x plus y upon x plus y into x minus y. Solving further, we get t x plus y into x minus y is equal to dx minus dy plus dx plus dy. Cancelling out dy, we get 2 dx is equal to t into x plus y, x minus y. Therefore, b, which is the distance between the two places, is t into x plus y, x minus y upon 2x. Again, this is a direct trick which can help you save your time in any exam. A man takes n times as long to row upstream as to row downstream the river. Then what is the relation between the speed of man and the rate of stream? Let us suppose that the speed of man is x km per hour and the rate of stream is y km per hour. Then we need to establish a relation between x and y in terms of n. It is given that the upstream time is n times the time needed to row downstream. The upstream time is d upon x minus y, which is n into d upon x plus y. We need to find a relation between x and y. So solving this further, we get d into x plus y is nd into x minus y. dx plus dy is ndx minus ndy. Bringing all the x terms to the left and all the y terms to the right, we get dx minus ndx is equal to minus ndy minus dy. Taking dx common, we get dx 1 minus n is equal to minus dy 1 plus n. That is, cancelling out d from both the sides, we get x is equal to minus y 1 plus n upon 1 minus n. We simplify it further so that it is easy for you to remember. We get x is equal to y into n plus 1 upon n minus 1. This gives us another very easy trick to be used in your exam. If you found this video useful, please like it and subscribe to my channel for more such easy tricks to crack competitive exams.